In basic ASCII, all characters are made up of 7 bits, which is an odd number in more than one sense. We can think of it actually as 8 minus 1. Computers usually communicate in octets, also known as bytes, a series of 8 pulses known as bits. So why would we only use 7? From our digital data lesson, you will remember that 8 bits can have 2 to the power of 8, which is 256 combinations. That's more than enough to send the letters of the English alphabet. So engineers at the time decided to only use 7 bits, which still gives us respectable 2 to the power of 7, 128 different characters to send. Yes, it's more than enough to transmit all the English characters, including letters, numbers and punctuation. This is known as the basic ASCII set. And its leftmost character is 0. The leftmost character is also known as MSB, most significant bit. Now, can you see why it is the most significant of all 8 of them in a byte? All computers in the world understand basic ASCII and display it the same way, regardless of the manufacturer or country. The remaining set of bytes, with MSB bit set to 1, was given to various equipment manufacturers and agencies to use for their own, often not compatible codes. So the same binary code could be an accented French character in one system and a signal to slow down transmission in another. This is known as an extended ASCII, and it causes confusion. Luckily, you won't find it very often with modern equipment. This 8th bit can also be useful for checking for errors in transmission. It can be used to store something called a parity bit. Parity checks are rough calculations done on the incoming data that let us know if during its long transmission down many hundreds of miles of cable, a 0 doesn't become 1 and vice versa. There are 2 systems that were popular, odd and even parity checking. But both are getting outdated now, replaced by something much more clever called CRC, for cyclical redundancy check. With the even parity system, the total number of ones is added together and it must equal to an even number. If counting the number of ones and the total is even, then the parity bit would be set to 0. And if it's odd, then MSB parity bit is set to 1. So the total number of ones in the byte is always even. The sending computer sets the parity bit and the receiver checks it, and if the parity bit is wrong, the character will need to be resent, as it has been surely corrupted during transmission.